For an AP, if you add or subtract or multiply or divide by a constant, the resulting sequence will also be in AP, arithmetic progression. Sum to n terms of an AP is n by 2 into 2a plus n minus 1d, which is also you can write it as n by 2 times a plus l, the first term plus the last term. Now, what is an arithmetic mean? If between two numbers you insert another number such that this inserted number becomes uh, uh, the with the inserted number, the sequence formed is an AP, then it is called as the arithmetic mean. An arithmetic mean between two numbers is a plus b upon 2. This is the arithmetic mean. Next, you can insert n arithmetic means between two numbers, and that means once you insert these n numbers, the a and these n numbers and b forms an AP. And this we discussed how these arithmetic means are. You can, we did this and then we just started a few problems. So we'll continue with further problems. The first class of it was on 21st December. That's 21st December class. Today is 29th December, 30th December. Few more problems on AP. In an AP, if pth term is 1 by q and qth term is 1 by p, prove that the sum of first pq terms is half pq plus 1, where p is not equal to q. So how do we do? Let a be the first term and d be the common difference. Then pth term a plus p minus 1 times d is equal to 1 by q. Then qth term a plus q minus 1 times d is equal to 1 by p. Now we want to find sum to PQ terms. N sum to n terms, right? So n by 2. So PQ upon 2 into 2a plus PQ minus 1 times d. So now we have to show this from this we have to simplify like this. So one way to do it is from this 1 and 2, solve 1 and 2 to find common difference, and a solve 1 and 2 to find a and d. So 1 minus 2 will imply 1 minus 2. If you subtract, you will get p minus 1 times d, q minus 1 times d. Subtract, you will get p minus q times d is equal to 1 by q minus 1 by p. So you get p minus q upon pq. From here we get the common difference is 1 by pq. If common difference is 1 by pq, what is a? So a, first term, is 1 by q minus p minus 1 times d from equation 1. 1 by q minus p minus 1 upon 1 by pq. This will be p minus of p plus 1 by pq. Okay, so you will get 1 by pq. Therefore, a is 1 by pq, d is 1 by pq. Okay, therefore, in 3, SPQ is PQ by 2 into 2A plus PQ minus 1 upon D. You will get this as PQ upon 2, 2 by PQ plus PQ minus 1 by PQ. So PQ, PQ cancels. I'll simplify it further. This is 2. There's a common denominator, so you can directly add the numerators. So 2 minus 1 will be 1. So you get PQ plus 1. Half of PQ plus 1. Okay. So that which appeared to be difficult, just by solving for A and D, we could simplify. Just direct substitution of formula. Is it clear?
Yes, sir.
All right. Next, they are sum to n terms. They are very good questions on sum to n terms. So we'll do them. These are very important models. The models that have been given in your textbooks are very important models. Based on that, many objective questions are built. Okay, you can tell me very fast this one, or no, we may not be able to do it fast. There's some missing information. If the sum of a certain number of terms of the AP of the AP 25, 22, 19, so on is 116, then find the last term. Find the last term.
Sir, I've done this problem before, so I know the answer.
Mm.
It's is it 4, sir?
I don't know the answer because I have not solved it. Meaning it is like I have not solved it immediately in the recent. So you tell me the solution.
So first, find the common difference, that is
Very good.
-3.
Very good. Common difference.
And A is 25.
1 second. Common difference.
Common difference is
22.
-3.
Right. First term.
And first term is 25. And sum of n terms is 116.
Sn
Is equal to
is
116.
n by 2 into 2a
2a plus n minus 1 times d is equal to 116.
Right.
By substituting a and d, we'll get the value of a. Sorry, we'll get the value of n.
So 2 into 25, 50 plus n minus 1 times -3 is 116. So now we'll simplify. N by 2 is 50 minus 3n plus 3, 116. So 50n, no, 53n, right? 50 plus 3 is 53. So 53n minus 3n square is equal to 232. So 3n square minus 53n equal to 0. So 116 times 2 is 232. Now divide by 2 again. You get 58 into 4. Let's divide again by 2. We have to factorize 19, not 19, 29. 29 to 8.
So 24 and 29.
24 and 29, is it? How do you get? You get 58 into 4 is 232. 29 into 8 is 232.
So there's 3 also, right? So for the x square coefficient.
Okay.
Yes, sir.
Okay. I forgot. That's right. So 29 into 24. Right. So 3n square minus 24n minus 29n. So 3n n minus 8 minus 29 into n minus n minus 8. So n cannot be a fraction. So n has to be 8. The other n will be 29 by 3, which is a fraction. So the term has to be a natural number. So n is equal to 8. So if n is equal to 8, then find the last term. A plus n.
So simply like put all the values in an formula.
Right. So last term, nth term, is a plus n minus 1 times t. So 25 plus 8 minus 1 times minus 3. So 25 minus 21, which is 4. Okay. This is the answer you got? Is this the
Yes,
answer?
sir.
Yes. So sum of certain number of terms of the AP is this. So find the last term. This was the problem, simple problem. Just concept is simple. Calculations you'll have to just bear in mind. Next. Now find the sum to n terms of the AP whose kth term is 5k plus 1. Did you do this?
No,
Keda?
sir.
Now there are two methods to do this. I will show the first method. Now kth term tk is given to be 5k plus 1, or nth term will be 5n plus 1. N minus first term, n minus first term will be 5 into n minus 1 plus 1. This is 5n minus 4. Minus 5 plus 1 is 4. Therefore, common difference will be nth term minus the n minus first term. 5n plus 1 minus of 5n minus 4, which gives us 1 plus 4 is 5. This is the common difference. What is the first term? Put n equal to 1. T1 is 5 into 1 plus 1. So 6. First term is 6. Common difference is 5. So sum to n terms, Sn, will be n by 2 into 2a plus n minus 1 times d. So n upon 2 into 2 into 6 is 12, first term, plus n minus 1 times 5. So I'll simplify this. It is 5n, n times 5n plus 7. 12 minus 5 is 7. So 5n square plus 7n upon 2. All right, this is the first method. Method 2.
So how is t to the k equal to tn? Like, I mean, how are they similar?
K term, right?
Yes, sir.
So you can directly say k term and k minus 1 term.
Okay. Okay. Yes, sir. Got it, sir.
That way also you can do.
Got it, sir.
Now the second method is based on this result. Sigma n, that is or sigma k equal to 1 to n. We write as sigma n, which is sum to first n consecutive integers. This is n into n plus 1 upon 2. All right, this is there in your result. I'll have to, yeah, sum to n terms of special series. Then there are proofs for this in section 9.7 of your textbook. You can see this. Sum to square of the first n natural numbers. 1 square plus 2 square, 3 square, n into n plus 1 into 2n plus 1 upon 6. These three are the most important results. Sum of the cube of the first n natural numbers. One cube plus 2 cube plus 3 cube plus n cube. It is n square of the first result. N square into n plus 1 the whole square by 4, which is sigma n the whole square. All right. These are the three critical results, and of course sigma 1, that is sum of a constant of first n terms, that is 1 plus 1 plus 1, it is equal to n. So use these results in any, suppose nth term is given or kth term is given. How to find sum to n terms? We can do like this. Now k term is given as 5k plus 1. So given tk is 5k plus 1. Now sum to n terms Sn will be sigma tk, k equal to 1 to n. So n terms, right? So sigma 5k plus 1, k equal to 1 to n. This will be 5 times sigma k equal to 1 to n times k plus sigma 1 time sigma of 1 k equal to 1 to n. Now from the previous result, this is sum to the first n natural numbers, 5 into n plus 1 upon 2, and sigma 1 is n. All right. Now you observe this. This is 5n square plus 5n plus, when you bring it to the common denominator, you will get 2n by 2. You get 5n square plus 7n upon 2. Same result. So in this, you don't have to find the first term. You don't have to find the common difference. You see the number of steps. In fact, I have written this step like this, but simply I would have written for objective questions directly sigma of this, write this step, and then the next step. That's it. Problem is solved. All right.
Yes, sir.
Next. Harshita, these tricks will be very useful for you for your exam, whatever the test that you're preparing.
Okay, sir.
Now, if sum of n terms, okay, this is. Hmm. Hmm. Okay, now sum to n terms is given. You have to find the common difference. This is also a good question. If the sum of n terms of an AP Pn plus Qn squared, where P and Q are constants, find the common difference. See this. Sum to n terms is given as Pn plus Qn square. What I'll do, I'll find sum to n minus 1 terms. I will replace n by n minus 1. Okay, so this becomes Pn minus P plus Q times n square minus 2n plus 1. So Pn plus Qn square plus 1 minus P minus 2Qn. Okay, so we need to find the common difference of Sn minus 1, Sn minus Sn. Okay, so we'll get the last term. So nth term is Tn will be sum to n terms minus sum to n minus 1 terms. Correct? These are n minus 1 terms. These are having n terms. So when you subtract this, what do we get as the nth term? So nowhere this is defined like this, but it is a common sense logic. So when you do that, you get Pn plus Qn square minus of Pn plus Qn square plus 1 minus P minus 2Qn. So the nth term will be this Pn plus Qn square cancels. you have P, or more appropriately 2qn plus P minus 1. Did I make a mistake? I made some mistake. This is not 1, this is q. This is qn square. So pn is there, minus p is there. Qn square minus 2qn plus q. This should be q. Okay. Now I got the nth term. Now to find the common difference, what should I do? I find the n minus first term, 2q into n minus 1 plus p minus q, which is 2qn minus 2q plus p minus q. Common difference will be nth term minus n minus first term. That is, strike off the nth term minus this, you get 2q as the common difference. Did you understand? Sum to n terms of an AP is given. Find the common difference. Another way to do it is, if you put n equal to 1, the first term will be p plus q. That is the first term. Sum of the 1 terms is, so first term is p plus q. Then you put sum to n terms, 2a plus n minus 1d into n by 2, and equate, you can find the common difference. But this method is more logical and more straightforward and very, very useful method, the way I've done it. All right, we'll go to the next. Some questions are good. I'm purposely skipping it. You can try them. Some prove that questions. Question number 11, very good. You can, it's a very standard, all IIT textbook problems will have this. Question 11, you can try that. Sum to n terms of two arithmetic progressions are in the ratio. Okay, let's do this. The sum of n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. Find the ratio of their 18 terms. Of their 18th terms. There are two different series. All right, and series 1 and series 2. I'll call this S1, sum to n terms. S2, it's not square. Maybe this is not square. Maybe we should write it differently. Generally, sum to n terms will have a common proportion. So let us say let k be the proportionality constant. No, let me do the other way. Let A1 and D1 be the first term and common difference of the first AP. Let A2 and D2 be the first term and the common difference of the second AP. ఏం చేస్తున్నా? All right. So then, first is n by 2 into 2a1 plus n minus 1 times d1. S2n is n by 2, 2a2 plus n minus 1 times d2. Now given S1 n by S2 n is 5n plus 4 upon 9n plus 6, which implies when you divide these two, you get 2a1 plus n minus 1 times d1 by 2a2 plus n minus 1 times d2 is equal to 5n plus 4 by 9n plus 6. We can compare the coefficients. Comparing, say numerator, the coefficient of n, comparing the coefficients of n in the numerator and denominator. So observe here. So coefficient of n is d1. So you get d1 is equal to 5. If d1 is 5, 5n. Now 2a minus d1 is 4. So 2a1 minus d1 is 4. So d1 is 5. So a1 is d1 plus 4 by 2, which is 9 upon 2. In the denominator, d2 will be 9. Then 2a2 minus d2 is equal to 9. sorry, is equal to 6. Given this is 6. Correct? The constant term 2a2 minus d2 will be equal to 6. So this implies a2 will be d2 plus 6 upon 2, which is 9 plus 6, 15 upon 2. So now you have found D and you have found A1. So 18th term, find the ratio of their 18th terms. 18 terms for the first. For first AP, the 18th term is A1 plus n 18 minus 1 times 18 minus 1 times d1. That is 9 upon 2 plus 17 into 5. So this is 179 upon 2. So now for second AP, the T18th term, A2 plus n minus 1 times T. So 15 by 2 plus 17 into 9. So this will be 34 times 9 plus 15. 321 upon 2. So the ratio 179 is to 321. Can we simplify it? Okay, it will not show you. I don't know whether they have common devices.
So I think 179 is a prime number.
Yeah, I also feel so. They're prime numbers. So 179 is a prime. So 179 is to 321. That's the answer. All right, let me check the answer. Yeah, 179 over 321 is the answer. Correct. All right. Now let's do problems on AM and some to, yeah, let's do problems on AM and GM. AM, not GM. GM I have not done. Geometric progression I have not done. Insert 5 numbers between 8 and 26 such that the resulting sequence is an AP. Resulting sequence is an AP. One is, you remember the formula. That will be, okay, you can remember the formula and do it. Other is, see, this is the first term. This is this second, third, fourth, fifth, sixth, seventh term. Okay. So first term is 8. T1 is equal to, now T7 is A plus 7 minus 1 times D is 26. So 8 plus 6D is 26. So 6D is 26. 26 minus 8 is 18. So D is equal to 3. So A1 is 8 plus 3, 11. A2 is add another 3. 11 plus 3, 14. A3, 14 plus 3, 17. A4, 17 plus 3, 21. A5, 21 plus 3, 24. Oh, no, something is, sorry, this is 20. 17 plus 3, 20. 20 plus 3, 23. Okay. So this is the way we can insert much easily by logic. You don't have to remember that formula. What is that? A plus n times d by n plus 1. Those formulas are there for, you can, when required, you should be able to do it, but not required. You can directly use this. Next. Okay, there's a logical question. Let me see if you can answer. If a power n plus b power n by a power n minus 1 plus b power n minus 1 is the am between A and B, then find the value of n. Answer? What's the answer?
So 1.
Yes, 1. Because you have to compare this with the AM between A and B is A plus B by 2. So you can see, just observe it. You can cross multiply and do other things also. But you can just see that by substituting n equal to 1, both sides become equal. All right. So by just substituting n equal to 1, both sides become equal. And so it's just by observation. If you have to do mathematically, you'll have to do a calculation. Last problem for today. The difference between any two consecutive interior angles of a polygon is 5 degrees. Okay, if the smallest angle is 120 degrees, find the number of sides. Find the number of sides of a polygon. Can you think of doing this problem? Give me ideas.
So we can equate the sum of this AP to n minus 2 into 180.
N minus
2 into 180 because that's the total sum of the angles of a polygon.
Okay. How do you find this sum? How do you know that sum of all the angles of the polygon is 180 into n minus 2?
So for triangle it's 180 and for quadrilateral is 360. So
Mm.
that's also a series.
Yes, very good. How do you find?
So we'll have an equation like
Sir, A is 120 and the common difference is 5.
No, no,
yes,
no. That is true, but I'm saying sum of all the interior angles of a polygon is 180 into n minus 2. I say, how do you get that? See this, let's say this is theta 1, this is theta 2, theta 3, theta 4, theta 5, theta 6, this is theta 7 here, okay, or theta n, let us say, and let each of these interior angles be alpha 1, beta 1, alpha 2, beta 2, alpha 3, beta 3, so on, okay. Now what happens? See, alpha 1, beta 1, 180 minus theta 1, okay. Now alpha 2 plus beta 2, 180 minus theta 2, correct? Alpha 3 plus beta 3 is 180 minus theta 3, so on. Now you have alpha n plus beta n is 180 minus theta n. Okay, here it's 7, but it will be uh, theta n. Now what happens? This beta 1 plus alpha 2 will give you one interior angle of a polygon. Okay, beta 2 plus alpha 3 gives another interior angle. Beta 3 plus alpha 4 will give like that, and then beta n plus alpha 1 will give the another interior angle. So when you do this summation will give us sum of all interior angles of a polygon on the LHS. Understood? Did you understand?
Yes, sir.
This is, each one is a triangle. Sum of two angles will be 180 minus the third angle. Sum of these two will be 180 minus third angle. Now when you add these two, you get an interior angle. Add these two, interior angle. Add these two. So when I add all of these, I get sum of all the interior angles of polygon, which is 180 times n. All right, n times 180 minus of theta 1 plus theta 2 plus theta n, which is, you see, it forms 360 degrees. So it is 180 into n minus 2. All right, your answer was right, but I just wanted to know how you get this. So sum of all the interior angles of a polygon is 180 into n minus 2. So the question is, find the number of common difference is 5. This is smallest angle is 120. So A is 120 degrees given. A is 120 degrees and D is 5 degrees. And sum of all the, if there are n polygons, n 1, 2, 3, 4, 5, 6, 7. If there are 7 sides, you will have, you know, n is equal to 7. All right. So how many interior angles you will have? 1, 2, 3, 4, 5, 6, 7. The number of interior angles will be same as the number of sides. So sum to n terms is n by 2 into 2a n minus 1 times d. This is equal to 180 minus n minus 2. Okay, sum of all the interior angles. So find n, find the number of sides. So let us do this now. I cannot take this inside. I'll multiply 2 both sides. I'll get n times 240 plus 5n minus 5 is equal to 360. Sorry, 360n minus 720 because 2 gets multiplied. So then we have 5n square plus 235n is equal to 360n minus 720. So 5n square minus 360 means 125. 125n plus 720 equal to 0. 5 taken common. N square minus 25n plus 5 ones 124. Correct.
So
Correct.
144.
144. Okay. 144. Right. 144. So 144 is 12 into. So let us simplify.
So 9 and 16, sir.
16 nines. So n is either 9 or n equal to 16. Okay. All right. So see, I've missed a number of classes. I'm thinking on first, it will be a holiday for you.
Yes, sir.
So we can have class on the first, on which I'll cover GP. If that is okay with you.
So what time will it be, sir?
I'll have to decide. I'll have to decide that once.
So why are we getting 2 answers in this question?
Let me see. You should not get 2. Let me see. Because if you have 16, no, if you have 16, I think you will get a convex polygon also. Let me see. You will get this is a convex polygon. There will be an irregular polygon. 16 means the question here is not said whether you will get a convex polygon. See, when will you get 180? 120, 120, 125, 130, 135, 140, 145, 150, 155, 160, 165, 170, 175, 180. Let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now 16 means you will get 185, 190, 197. So your polygon will, it's a convex polygon, means the interior angles will be less than 180. Now you can have a polygon like this. Understand? Where the interior angle can exceed 180.
Okay, sir.
Okay. So in that case, what happens is, uh, so in that case also, find the number of sides. The smallest angle is 100. In that case also, sum of all the interior angles, I don't know how it will be. I think if it's a convex polygon, answer should be 9. If it doesn't, if it's goes to this kind of a polygon, then answer can be 60. Understand?
Yes, sir.
All right. So on first, I will see what time should I fix. I'm not sure. I'll prefer morning time, unless you are having a midnight, New Year Eve celebration. I'll prefer sometime in the morning half. It'll be fresh.
I'm fine with that, sir.
Okay, maybe 10 to 11:30 or 12, like that. How about you, Kedar?
Yes, I think 10 is okay, sir.
Okay.
Yes, sir.
So as of now 10, but I will announce.
Okay, sir.
Okay, tomorrow. All right, we'll close.
Thank you, sir.
Thank you.
So please take those questions.
Which ones?
Sir, I sent you.
All right. Okay, Kedar, you can drop. You can log off.
Sir.